Good day, students. Welcome to another GeoGebra class. In this class, we want to look at how cloning of triangles. There are various ways you can clone a triangle. So we are going to start by first inserting a triangle into our GeoGebra worksheet. So using the polygon tool, we can insert a triangle using these 3 points. So our triangle has a base of 6, and then the other sides are 5, and then 5 here. So this is an isosceles triangle, and the area of the triangle is equal to 12. So we should be able to move this triangle. So we can leave it like this. So in this way, it's no longer an isosceles triangle. We can see all the different sides. So this is a scalene triangle. All the sides are different. The area is currently 11.28. So let's clone this triangle using different methods. So the first method we are going to use is the side method. So what this means is that we are going to first clone this side, clone the other side, and then clone the third side as well. So we are cloning all the sides. And then when we are done, the triangle that we have as the clone of this should have the same size as this triangle, the original triangle here, and then should also have the same area as this triangle. Okay, so let's begin. So the first thing we're going to do is we're going to go to segments with given length, and we will create the base of this triangle here. So I'm going to put the point here, and then the length is A. So I'm going to use A. Although A is equal to 6, I won't type 6. I'd rather type A, so that when A changes in the future, due to me moving these points, the clone will also move in accordance to the original triangle. Okay, so we are going to use A. So we have it here. This is the first side that we have cloned. Then it will be the same segment with given length. We'll start at D. This time we'll use the other side. So let's say C. Okay, C. Then we get the other one. So for match cleaner worksheet, let's move the new point F somewhere up a bit like this. Okay, so that everything is visible. Then let's go back to segments with given length. Then we'll start at E. Then we'll enter the last side, which is B. Then we have it like this. So let me zoom out a bit so that you can see all the points. Then we'll go to circle with given with center through points. So we'll start at D, open our circle to F, and then click to put a circle there. Then we'll start at E and open our circle to G. So it's like this circle here is giving us a radius which is equal to the length of F, which is one side of this triangle. And then this other circle is also giving us a circle with radius H, which is equal to another side of this triangle. So the points where these two circles will intersect, the radius of this is equal to this side, the radius of this other circle is equal to the other side, and they meet. So we'll be able to get a triangle. We'll be able to get this third coordinate of the triangle there. That's why we did that. So we will go to the intersect two, and then find the intersection of the two circles by clicking on them. So you click on the first circle, then you click on the second circle, and then these are the two points of intersection. So let's remove the circles. We don't need them again. We have the points of intersection. So we can just use our polygon to wrap up this point of intersection at the top here, D, and then E as well. Okay, because this is the base, and then this is the third point of the triangle, the third vertex. So we got that by using circle with given uh, length. So we use this length to generate a circle, this length to generate a circle, and the point of intersection gives us the third vertex. So when we remove more of the unwanted elements here, like the point F, we don't need point F, we don't need the segment F, we don't need the segment G, we can hide it. Then we can hide H as well. Then we can hide the point G. So now, and then the point I as well. Okay, so we have this here. When you look at it, it looks like a clone of it, right? It looks like a clone of it. So we'll come to the algebra view. Now look at the three sides of the triangle. The original one, it was 4.21, B was A is 6, and then C is 5.56. When you look at the clone, D1, which D1 has a length of 4.21, and you see this is D1, it corresponds to B here. So B is 4.21, D is also 4.21. H1 here corresponds to A. So H1 is 6, A is also 6. And then E1 corresponds with C. E1 is 5.56, C is also 5.56. The area of the original triangle is 11.28. The area of the clone is 11.28. So that means that we've been able to successfully clone this triangle using side, side, side. So I'm going to input that here, side, side, side. Okay. So that was the first approach to proving to cloning this triangle. That was the side, side, side approach. So let me just beautify the right up here and then we proceed from there. Okay. So we can move on. So the first one is the side, side, side. Now we are going to look at other ways that we can clone this triangle. So we've looked at side, side, side. The next one we want to look at is side, angle, side. So side, angle, side, what is it about? So side, angle, side. So here the issue lies in which one lies in the middle. Okay, so the middle one. So side, angle, side means that we are going to have one side, then the angle will be in the middle, then the other side will be drawn. Okay, so that's what we mean by side, angle, side. So side, angle, side, we'll first draw the side, and that will just basically be the base. The side we are going to draw will be the base. So I'm putting random points. So I'm going to put a point there, a point with okay, segment with given length. Let's use segments with given length. So I'm going to put it somewhere here, and the length I want it to be A. Okay, small a, and small a is the base, the length of the base of this triangle. So that's exactly what we're also using. The points we place here doesn't really matter. We could place it anywhere. So currently the value is 8, negative 8.93. It doesn't really matter. What matters is that the length of this segment here is the same as the base here. Otherwise, then it's not going to work. So we have first created the side. Okay, so we are using side, angle, side. So we've created this side. So the next thing is to create the angle here. Then the next is the side. So we are going to clone. So we've created this side. Now we're going to clone the angle here. Then we clone this side. So with that, we are going to go to angles tool and then find all the interior angles of this triangle. All right, so we have them here. Then now we know that the angle here is alpha, is gamma, and it is 63.19. So we go to um, angle with given size. Then we want the angle to be at K, and we want the value to be equal to gamma. So let's try this and see if that works. Gamma, and it should move clockwise. So let's see. Okay, so we have it here. And then this is a point where this line passes through. Okay, to get the angle, this point and this point must be connected. So we can do that using the ray tool, and then we click on this point and then that point. So we have a ray here. So we need to intersect this ray to get exactly the length of this side of the triangle, which is B. So to do that, we'll use a circle with center and radius. So we want the center to be here and the radius to be equal to B. Okay, so that's where the circle will intersect the ray. That length there, or that radius there, is exactly the length of B. Okay, so we'll go to our intersect tool from here. Then we'll find the intersection of this circle and this ray. Then once we have that, we can remove the circle. We can remove the ray as well. And we don't really need the J prime as well anymore. So the next step is to just use line segments, or we can even just go straight away to use the polygon tool, since we now have the side here. So we will be able to create our polygon. And as always, we can check the coordinates to make sure all the sides are the same. So this side is should correspond to A, and that's I. So I is 6, A is also 6. Then B is 4.21. So J1 should also be 4.21, which is here. Then K1 should correspond to C. C is 5.56, and K1 is also 5.56. Then you can see that the area is 11.28 in the in the original um triangle, and the area for this clone is also 11.28. So you see we have successfully cloned this using side angle side. So we created this base here. The first side, we cloned that one first, then we cloned the angle, then the side, okay, this side as well. Then once you clone this side, the other side is just connecting this point to the other point here, and then you have the triangle. So that's why we call it side angle side. So the angle is in the middle. You create the side first, you create the angle which is in the middle, then the other side, and then you automatically get the third side. So we are going to go to the text box and insert the same thing. So here, this one is side, angle, side angle, side. Okay, so let's edit that one to a bit. So side angle, side. Let's change the background, the color, and the text. Okay, so let's move on to another one. This one is side. Let me see. This one is the next one is angle, side, angle. Okay, so you see, although the next one is angle, side, angle, we won't be able to create the angle first, because to be able to create the angle, we need at least a line segment. So instead of creating the angle first, even though we are going to be working with angle, side, angle, we will rather create the base of the triangle first. So we'll clone that one first. So somewhere here, then the length is A, as we've been doing, to get the base of the triangle. Then angle side angle means that there is one angle here, and then there is one angle also at end. So it's like angle, then the side, then the angle. The side is in the middle of the two angles. That's why we call it angle side angle. So let's create the angle here. Let's create the angle here. So we know the angle here is beta here. Okay, it corresponds to beta. Then the angle here corresponds to alpha. Okay, it corresponds to gamma. And then once we get those two angles, the third angle alpha will automatically be equal. So we'll go to our angle with given size. So let's start by putting beta first. So we want it to move counterclockwise, and the angle is beta. Okay, then the other angle to be created on the other side, we want it to move clockwise, and then the angle is gamma. Okay, so we have these two points where the line must pass through. So just like we did for the first one, we are going to go to ray, then use ray to pass through this, then use ray to also pass through that. Then we will use the intersect tool to find the intersection of the two rays, and that should be the third coordinate that we need. So we can remove the ray, and then we can remove M and N. We don't need them anymore. Oh, okay, not M and N, but rather N prime and M prime. Okay. Then we can use the polygon to wrap it up. To wrap it up. Okay. And then N1 must correspond. So um let me remove M. Okay. Let me remove I as well. All right. So O must correspond to I. So O is 6, I is also 6, and I corresponds to A. We already verified that. M1 should correspond to J1. M1 is 4.21, J1 is 4.21, and J1 corresponds to B, which we already verified. So N1 must also correspond to K1. So M1 is 4, N1. So N1 is 5.56. K1 is also 5.56, and K1 corresponds to C. We already verified that. And then lastly, the area is 11.28. The area is 11.28 for this one as well. And for the original one, so it is 11.28. So you see, the angle side angle is also another way of cloning any triangle. So you create the side first, then the angles on the endpoints of the side. So that's why we call it angle, side angle. The side is in the middle of the two angles, okay? So let's do the same thing. Let's put a third box here, and then let's call it angle, side, angle. The side is in the middle of the two angles. Then let's edit that a bit, and then we can proceed from there. So let's change the background to gray, bold, and choose blue, large text. We have that. All right. So as you can see, there are several ways of cloning a triangle. Okay. So you can either use the side approach, side approach, or the angle side angle approach. Either way, you'll be able to successfully clone a triangle. Okay. So there is one approach that people talk about but does not work. Okay. And that approach, it does not work. You won't be able to successfully get the cone of the triangle, and that is the side angle approach. Okay, the side angle approach does not work. The one side will not necessarily or always be equal to the third side of the other one, and you can do that as an assignment to try it out. Okay. But the way to go is that first, so it's like side angle. So we know that we are going to create two sides and then one angle. Okay. The angle is going to be at the far end. So we can use a segment with given length. So let me try to create that right here to show you something. So the length is going to be A, small a, like we've been doing. That's creating the base, the clone of the base of this triangle. So we have created one side. So it's side angle. Then we create the other side and then the angle, or the angle, we can also create the angle and then the other side. So let's do one of those and let's see. Okay, so side angle. So we have created one of the side, so we'll create the other side as well. Okay, so like the way we did this side, we created the first side, we created the second side, then we used we created all the three sides, then we use circles to find the intersection. So for this one, we've created the first side. We're going to use segments with given length again to create the other side. Let's say C. So C will be created at P. Okay. And just like the first one, let's move R a bit to the top. Okay. So something like this. So we've created this side, we've created this side. So the next point is to find the angle here. to find the angle here. So you realize that if I find that angle, so if R corresponds to C, then the angle at the top here should be alpha. So if I come to angle with given size, I want the angle to be at R. I want it to go clockwise, and I want it to be equal to alpha. Okay. Okay, so it should have gone counterclockwise rather. Okay, so let's delete it. Okay, so let's try that again. This time around, let's leave it as counterclockwise. And then let's select alpha. So when you press OK, now we have the actual one we need. So the issue now is that we have to make sure this, okay, intersects with this. So let's try something. Let's use circles. Circles. So first, let's put a ray. Okay, like the way we've been drawing. Let's put a ray to pass through this. Then, um, so when I move R further, okay, to something like this. So you see that with something like this, you can see that the ray is passing through Q. Okay, and the angle here is alpha. Okay, so let's use the polygon tool to wrap it up. Okay, so when you use the polygon tool to wrap it up, you see, in order to make the ray pass through Q, I had to use my eyes to adjust. Okay, to make sure it passed through Q. Now, if I use that to do it now, look at this. You see that the area here is 11.09. Do you see that? It is not equal to the area of the actual triangle, which is 11.28. Okay. So what I did is I've created side, I created the other side, and then I created the angle. So side angle. Okay. But it does not work because when you are done, one of the sides may not necessarily be equal. And P1 P1 here, when you compare it to J1, J1 is 4.21. Okay, J1 corresponds to B. J1 is 4.21, but you see that P1, which is this side, which should have corresponded with the J1, it's not corresponding because P1 is 4.13, but J1 is 4.21. So there is an error with this side. Okay, and that's because for the ray to pass through this point, you are doing it manually, and there is no guarantee that this length here is going to be equal. There's no guarantee that this length here is going to be equal to the other side of the triangle. So when you do one side, then you do another side, and then you clone an angle or side angle, the third side may not be the same. Okay, in some unique, very unique cases, it will be the same, but because it doesn't work for all, we don't consider it as a way of cloning a triangle. Okay, you don't consider it as a way of cloning a triangle. So all these three here, that's the side angle, side angle, they work for all triangles, all scenarios. Okay, so this one, which is side, side angle, it doesn't work. Okay, you can't use it to clone all triangles. Okay, so I'll remove that one and then we'll just leave this for the ones that work. We'll just leave them there. So let's just remove the others. Let's just remove this one that does not work. And let's leave the ones that work. So this is what we wanted to do today. So the last thing we'll do then we'll end is to just insert an animation to make these points move and everything moves on its own. So to do that, I'll just go to slider. So I'm supposed to move this manually to show you that if I move these points around, all the other clones will also move in accordance to the movements of these 3 points. But I'll just use slider to automate it. So I can call it T, anything I want. Then for the interval, I'll do it um from, let's say, 10. So let me check. Okay, so I can do it from -10 to -2. That's fair. So it will remain in the quadrant that it is in. I can do the increments one for now and see how it goes. Then for the animation, I want it to oscillate speed one. So let me do that. Okay. And then turn the animation on and see how it goes. Okay. So this T has not been inserted into the A yet. So we go and double click on A. Then we change the X value to T. And when you do that, you will now be able to turn the animation on. Okay, so it's moving all right, but the speed is slow. So the increment 2 was 1. So let's fix that. To go to the object properties. Okay, so you can use this to learn about animations. Okay, but we are done with what we want to do today. So I'm going to reduce the increment to 0.1 to make it smooth. And then I'll increase the speed to 3. Okay. Then now turning back the animation. Okay, so you see now it's smooth now. It's moving smoothly. And as that point is moving, you can see that the other clones are also moving as well. And at any point of the animation, if I just turn the animation off randomly, the angles, so let me use the angle tool here to find the angles of all the others. Okay, so for this one there is some extra angle, so let's delete one, and this one, so there's an extra angle here, so let's delete. So I want to show you all the angles, so angle this and this. Okay, so as you can see, 75 here, 75 here, 75 here, 75 here, 44, 44, 44, 44, and then 59, 59, 59. At any point of this, okay, animation, the slider, at any point where I stop, it will have the same angle for all the triangles. So the cloning works for all types of triangles in all scenarios, except for the last one that we saw. All right, so this is just something small on cloning of triangles. I hope you have learned something today. So thank you very much, and hope to see you in the next video.